Hi, my name is Randy Sargent. I'd like to show you Earth Timelapse, which shows how our planet has been changing over time. This is a collaboration between Google's Earth Engine project and Carnegie Mellon's Create Lab. Let's start off with fires from space. We're looking at 1 year of fires from orbit. And what you see is that in some places the fires are quite constant, in some places they're quite seasonal. So if we zoom into Africa, for example, we see the seasonality where there are fires burned in the north of the equator, south of the equator. Let's turn on the color base map, and you'll see the forest along the equator. And then these fires are happening in the grasslands and the savannas, places where there is seasonal growing either grass for grazing or farms that are planted. And you'll see these fires happen before the growing season to kind of kill off what was on the ground. If we move over to Southeast Asia, you'll see the same sort of pattern, but here it marches from south to north. So watch it move up through Nepal and India here. And what you see is that happening every year, and it's evidence that the growing season starts later the further north and the further, the colder it is up as you go north. There are other sorts of fires we can see too. So if we zoom back out to Africa, I'm going to go back to the other background here, and you'll see these very bright fires that are on kind of all the time. We can see them also in the Middle East, and these tend to be places where we're extracting oil. These tend to be places where we have oil wells that are also flaring a lot of gases. It might be methane, might be some of the lighter gases. So if we turn back on the color-based map and zoom in, this is in Iraq, and we can get a sense of kind of how dirty those flares actually are. Let's zoom back out, and now let's move to the United States and see what we see there. In the United States, we have a little bit of seasonality. So if we zoom in and you look at Kansas here, Kansas and Oklahoma, you'll see once a year, kind of in this area, you'll see all the corn fields burning. But mostly we don't do that sort of thing in the farmlands. What we do see is these three very bright areas, of flaring that are massive. You can see them, from space quite easily. So we're looking at 2 oil fields in Texas and 1 in North Dakota. And these oil fields are using a new form of extraction called hydraulic fracturing or fracking, where oil or gas is taken from shale using a new process. And what we see is that most of the places in the United States where we frack, we extract mostly methane, natural gas. But in these 3 places, we get more oil than gas. But what happens to the gas? So if we zoom into North Dakota, for example, we'll see these massive area flaring. Almost all that methane that comes out of the ground along with the oil gets burned because there's nothing in North Dakota to really make use of that methane. There's no infrastructure to say convert it to electricity or things of that nature. And estimated in North Dakota that 1/3 of what we're taking out of the ground is in the form of methane. So if you look at this from a carbon standpoint, if the energy we're taking out of the ground, 1/3 of it gets burned immediately into the atmosphere, which is not particularly efficient. And it's often used as an argument for why something like pricing carbon in the atmosphere would help change our decisions, because it would make a lot more sense if we were pricing carbon to do something like turn that methane into a form of energy that we could use, like electricity, that's fairly easy to ship. We can look at other forms of carbon extraction from the planet. Let's go to a different satellite. We're going to move to the Landsat system of satellites, which takes us all the way back to 1984. And what we're going to see is a 30-year time lapse of the surface of the planet. We can zoom in anywhere we want to. The 30-year time lapse is a product of Google's Earth Engine system, which takes this historical scientific satellite data and makes it available for scientists to do various sorts of analyses, which we'll see in just a little while. But right now, if we zoom in here, we're in Queensland, Australia, where we're looking at a coal mine expanding over the period of 30 years, starting in 1984. Now, of course, we have coal mines across the planet. Not all of them are above ground, but we can look at several of them. Let's look at another coal mine back in the United States that uses a different form of extraction called mountaintop removal. This is in West Virginia, and what we're going to see when we zoom in here is on the order of 8 or 10 mountains literally being flattened. So the tops are being taken off and dumped into the valleys to give access to the coal. It's not all that great for the water. We're looking about maybe 50 kilometers east to west right now. Let's zoom out a bit to see more of a sense of the scale of what's happening. Now we're looking at maybe 200 kilometers east to west, and we're looking at several dozens of mountains. If we keep zooming out, we're going to see hundreds of mountains over the span of several hundred kilometers. So there are other forms of extraction we can see in the Landsat record. If we go to Alberta, Canada, we'll find the tar sands extraction. Tar sands extraction is a particularly inefficient form of energy extraction in the sense that half of the fuel that's taken out of the ground is burned in order to process the other half. It's a very thick, tarry substance that comes out of the ground, and you have to heat it up and melt it. And that means that we end up taking half of the carbon that we take out of the ground. We burn it and put it straight into the atmosphere. So it's even worse than the Bakken Shale in North Dakota. So we've looked at a lot of different forms of pulling carbon out of the ground. Let's look at some of the things that are really driving. Why are we doing this in an expanding fashion? Let's take a zoom out, and we're going to look at cities across the world. We'll see kind of the rapid industrialization. Let's move first to China, where in the past 30 years, lots and lots of people have been moving from farms to the cities, increasing standard of living and using more resources. We've zoomed in here to Shanghai, and you're seeing at the very beginning, Shanghai is this fairly compact city, and by the end, by present day, you see it's connected to kind of all the other cities in the area. I'm going to pause and go back to 1984, and then let's jump to present day, just to kind of show the contrast between the two. It's quite impressive growth. Of course, it's happening all over the world, not just China. We can go to the Middle East and take a look at Dubai, for example. Let's zoom in here to Dubai, and you can see one of the big landmarks that kind of show the amazing resource use there is these 3 sets of artificial islands, the 2 Palm Islands and the World Islands up to the north that were built in the past 30 years. We can go other places on the planet. Let's go take a look at Dallas-Fort Worth, for example, in the United States. Dallas-Fort Worth is sprawling quite incredibly right now. This is Dallas on the right, Fort Worth on the left. And if we zoom into the north of Dallas, you'll see kind of the farms turning directly into the cities and suburbs. I'm going to pan a little bit to the west here. Now we'll be north of Fort Worth. And if you look closely at the video, what you're going to see is that in the last few years, all these funny little white rectangles show up all across here. And it's easy to see in the farms. It's a little harder to see as you get to the suburbs up and around the houses. This is more hydraulic fracturing. So this is a fracking in an area where primarily natural gas or methane is extracted, but because it's so close to a city, it's very easy to make use of that energy. But we see this form of extraction all across the United States right now. If we zoom out, we can look at the growth of the city in a different way. So we're looking at the 30-year animation of Landsat right now. Let's switch over to a different satellite. So we're going to look at lights at night, which you've probably seen before, but we're going to show it in a different way here. We actually have lights at night going back about 25 years, and we can use that to actually show trends and show how places where the light's getting dimmer over time, places where it's staying the same, or places where it's getting brighter. So this is, again, Dallas-Fort Worth area with Dallas on the right. In green, we have the areas that have mostly stayed the same. So you see kind of the middle of Dallas and the middle of Fort Worth, which had already kind of been connected at the beginning of the 25 years. That stayed about the same. Then in the red area kind of around it, those are places where the light got brighter. So you really see kind of where the city was growing, where both cities were growing. Let's zoom out about a bit to the rest of the United States, and we'll see kind of other cities kind of ringed with red where they show a lot of growth, like Atlanta here or Phoenix over here. You'll also see two of the three massive oil fields that we saw in the flaring earlier. You see the Bakken and this one here in Texas. Let's zoom out a bit to the whole Earth and look across the planet, and you'll see kind of this giant area of red over here in China, of course. China and India both, but China is particularly impressive. You see, the whole country is practically red, meaning that it's brighter than it was, and a lot of people use that as a proxy for economic output. So if you imagine that, you'll see kind of the economic output. This is, again, Shanghai where it started, and then the whole area now is emitting light at night. So we're seeing a lot more use of resources to produce those lights, of course, but it's also indicative of all the different processes that are going on, which are all forms of economic output pretty much. If we go zoom out a bit, we'll see in contrast, Japan is putting out about the same amount of light it was 25 years ago. So it hasn't changed so much, which is consistent with the economy there. If we go to South Korea, we see kind of a big red ring around Seoul. And then we see it almost looks like an island because North Korea simply doesn't really show up at lights at night. There's kind of nothing. Not that it stayed constant, but it was kind of went from nothing to nothing. Zoom out a bit more. Let's go to Europe, and we can take a look at different countries and kind of see very different stories. So Ireland, for example, is like fairly red. This area here is Poland. So you can see that Poland has been very successful economically in the past 25 years since the Iron Curtain fell. And if we go over to this blue area, we don't see much blue on the planet. Blue is an area where the lights reduce over time, and this blue area is Ukraine. So let's turn on the map, and you can see the boundary, and then we'll go back to lights at night. So we've seen kind of some of the drivers of taking more energy out of the ground, but there's another consequence of growing population, and population is becoming more affluent, which is that there are more agricultural needs. We're taking more food from the planet, whether it's in the form of vegetables or in the form of things that we feed, say, cows for beef. Let's go look at forests, which are really suffering in part because of the conversion to agriculture. So let's go, for example, we're going to zoom in to the Brazilian state of Rondônia in the Amazon here. And if we start at 1984, we've zoomed into kind of a small part of the Amazon rainforest. You'll see it's quite dark green. This is the color of kind of the original forest before civilization started to modify it. And let's grab the time slider and move from 1984 forward maybe about 5 years. And what we see is we see a big road coming across. We see the beginnings of the north-south roads. We see a little bit more in the future, and we see this small town being built, and we see some more of the expansion around the roads of forest turning into farmland. Move forward maybe another 10 years, you'll see that the town is quite large now. You'll see all of these farms have grown quite large. And if we move to present day, almost all the forest now has turned to farmland in this little square of the Amazon. So this is about, again, about a 50-kilometer east to west. I'm going to animate that, and you can watch it happen. Let's zoom out and get more of a sense of scale. Let's speed up the animation again. So now we're looking at maybe 300 kilometers east to west. Let's zoom out more. And now we can see almost the entire Brazilian state of Rondônia, and you can see the expanse of the deforestation. And we're looking at maybe 1,000 kilometers east to west now. Let's keep zooming out. Now we're looking at more than one state. We're looking at Rondônia, Mato Grosso, Pará. Keep zooming. And if we zoom out enough, we're going to get to the point where you can see the Amazon River itself. We can see the mouth of the Amazon up here. And we can see the entire southern extent of the Amazon rainforest, almost the whole thing here. And look at the arc of deforestation across the southern extent. This is all land that's being turned, pretty much all into farmland of one form or another. But a lot of it is for raising cattle, and then some of it is for soybeans as well. Now there's another way, like we did for the cities, there's another way we can look at the loss of forest. We're going to turn on an analysis layer that was built by Matt Hansen, a researcher, Matt Hansen at University of Maryland, using Google Earth Engine, using the historical satellite data. We're going to turn on forest loss by year. And what you see in forest loss by year is places that are colored or places that we lost the forest sometime between 2000 and 2014. So we'll zoom back into Rondônia here, and what you're going to see is areas in yellow are areas that were cut down in 2000. Areas in red were cut down in 2014, and the colors in between are years in between. And what you see when we look at Rondônia is that there's a lot more yellow than there is red, meaning that more trees were cut down in the year 2000 than there were cut down in 2014. So in other words, the rate of deforestation is slowing down in Rondônia. And in Matt Hansen's analysis, if you zoom out to the rest of Brazil, you see that that's more or less consistent across Brazil, that as a whole, Brazil's rate of deforestation is slowing down. In other words, it looks more yellow than red here. If we go to the south, to Paraguay or Argentina, we'll see areas that are much more red and orange, showing that there's more being cut down today than there was back in 2000. So Paraguay is an area, for example, where deforestation is speeding up. And if we zoom out, we can look at the whole planet under this very same analysis. We can zoom in, for example, to Indonesia and see areas that are quite red and quite orange there as well. So we see accelerating rates of deforestation in Indonesia. So we've seen carbon that we're taking out of the ground and putting into the atmosphere. We've seen loss of forests, which also puts carbon into the atmosphere and reduces our ability to capture it into the soil. What does that do to the atmosphere? So I'm going to show a chart that may be familiar to some. This is a measurement of carbon dioxide over time, summarized by NOAA. And what you're seeing here is a graph going up over time, starting in 1980 or so. This oscillation up and down is a measurement of carbon dioxide in the northern hemisphere. And what you see, the oscillation is seasonal. You're seeing that every summer, as the plants grow, they take the carbon dioxide out of the atmosphere into the plants, and then every winter, the majority of the plants, decay back into the atmosphere. So that's what you're seeing is kind of the oscillation up and down. The thing that concerns us a lot more than that oscillation, of course, is the overall trend upwards. So if you see back in 1980, we were below 340 parts per million of carbon dioxide in the atmosphere. And then as we move forward, we're seeing this overall trend, which is coming from all that carbon we're taking out of the ground and burning. It's coming from the things we're doing to the forests. And you'll see that, present day we're over 400 now parts per million. So that's just in the past, since 1980. We can go back in time to 1960 when we first started measuring carbon dioxide in the northern hemisphere. This measurement is in Hawaii, and you'll see back in 1960 we were below 320 parts per million. To go back further than that, we have to use ice core samples in Antarctica. And what you'll see here is that the place where we really started to kick into overdrive is right around the time of the Industrial Revolution, right around the time we started burning coal and then oil. So you'll see that before the Industrial Revolution, we were around 280. So we've caused this massive shift from 280 to 400 in the atmosphere just since the Industrial Revolution. So what sort of problems does that cause? So let's take a look at another time series. This is going to be from the Berkeley Earth Project, a time lapse of temperature anomaly. And we're using roughly the temperature of around 1950 as baseline. And you'll see that the temperature has been rising since around 1900 or so. You'll see in 1900 it was significantly colder than 1950. We're moving forward in time, 1920, 1930. You're starting to see it more or less become even here as it rises. We had a plateau from 1950 to maybe around 1970 or so from the Berkeley Earth data. And then from 1970, it really starts to kick into high gear again and start to heat up again. And you'll see across the planet, the heating is not necessarily uniform. So, for example, the North Pole gets a lot of the what they call a temperature anomaly, the difference between kind of average and the current temperature. So places that rise quite a lot in temperature. So what happens when the North Pole, for example, is getting hot? Well, we can look at the ice pack in the North Pole. We're going to look at a time lapse from NSIDC starting in 1987. So we're going to look at the North Pole. And this is a map of the ice in 1987 in January, and what you're seeing is the extent of the ice. In the winter it's quite wide in 1987, and we're covering a lot of area. But what we're seeing in color is the age of the ice. So in white we have the oldest ice that's 10 years old or older, and we see like in dark blue the newest ice. So it's maybe 1 year old or less. And that's going to be the thinnest ice, and the oldest ice will be the thickest ice, generally speaking. So let's play forward and watch what happens to the ice. So people generally know that the ice cover on the North Pole has been reducing over time. But what this video shows is that in addition to kind of the area covered by the ice, the extent of the ice reducing, we're also losing the oldest and thickest ice, so it's becoming thinner at the same time. We can also look at what happens to the ocean in climate change. We're seeing areas that the ocean becomes hotter over time, but it also becomes more acidic as we get more and more carbon dioxide liberated to the atmosphere. A lot of it dissolves into the ocean, and in the same way a carbonated soda is very acidic. The ocean is becoming more acidic too. One of the problems there is that makes both of these effects make it harder for coral to grow. So let's start this animation back at the beginning. This is from NOAA's Coral Reef Watch, starting in June of 2013. And what you want to look for is the different colors here. The pale blue are nice places for coral to live. Places in yellow or orange or red, or the dark red is kind of the most dangerous. Those are places that are not currently hospitable for coral. So they're places where the coral will be under stress. Coral under enough stress will start to bleach and start to die back. And what we're going to watch here starting in, again, 2013 is a map that NOAA builds from satellite data to show where the places where coral is most likely to bleach and to die back. You'll see kind of these areas of red and orange come and go, but especially recently. So we have like here we're June, July, August of 2015. Here we are in September, and we have just these massive areas across the Pacific and some across the Atlantic, which are not hospitable to coral anymore. They're going to cause the coral to bleach. And indeed, when the divers go out and take a look, we see that we're in one of the largest recorded instances of coral bleaching across the planet right now. Now we can also see evidence of the planet heating up in Landsat. So let's go back to the Landsat time lapse, and we're going to zoom into a glacier in Alaska called Columbia Glacier. Let's hit play. We're starting in 1984. This is the first part of this is the frontier of the glacier. And let's hit play. And we're going to watch this glacier shrink all the way back up to the top of the screen. So it shrinks about 20 kilometers over the space of 30 years. Now I want to also take a moment. I realize that's a bit depressing, but let's take a look also at some of the more beautiful areas of the glacier. If we look in here, and again playing through the animation, you'll see some years that turn bright white, and those are years that we had too much snow on the ground to really see the ice very well. But if you look around the bright flashes and look instead at the ice, you'll see these beautiful patterns, and you'll see kind of the flow rate of the ice. You're going to see like this very slow moving river of ice, how far it moves over the course of 30 years. Let's go look at some other glaciers. We're going to move to Mendenhall Glacier in Alaska as well. And this one is perhaps more typical of glaciers we see. It's retreating maybe about a kilometer over the space of the 20 years. We can see other sorts of things. So if we go to, if we look at liquid water, surface water, we see places on the planet where the water is drying up. And it's a bit of a complicated story. So we're here in Lake Urmia in the northern part of Iran, and we're seeing that probably most of the drying up that we see here over the 30 years is due to diversion of the water that has historically gone to the lake, diversion of water into these green agricultural areas that ring the lake. So these planted areas are diverting the water that used to go to the lake. If we go to the Aral Sea, we're seeing drying up happening at a much larger scale. This is a lake that was hundreds of kilometers north to south. And here we see kind of a combination of agricultural use of the water that used to go there here to the east and to the south, but also we see drought causing a lot of the water loss as well. Let's zoom in a bit to one of these agricultural areas and kind of look at the frontier, if you will. This is right on kind of the southeastern edge, just below Aral Sea. And if you look really closely, you'll see kind of starting in 1984, it was all green in this area. Then we expanded to the east like this. And then if you watch the last 10 years or so, that area dries back up. So you can see kind of the expansion of the agriculture, kind of the greening from the west to the east, and then they have to give up on that land. There's simply not enough water to keep doing that. So you're kind of watching the peak green, if you will. We can see places on the planet where we see more fires than historically you would see. These are fires in Australia. Let's take a look, and I'm going to slow it down just a bit. And what you're seeing here are these white scars that appear each year. Each one of these is a large fire, and you can kind of see which way the wind was blowing with each of these fires. Another place on the planet we can see evidence of climate change. This is in Colorado, but it's also across more areas in the U.S. and also Canada. We talked earlier about how loss of forest leads to more carbon in the atmosphere, but the converse is also true. As we're heating up the planet, some of the trees are becoming stressed. And in particular, if we turn on the forest loss by year, we're going to see these areas in yellow and orange really light up. These are places where trees have been lost to the bark beetle. The bark beetle is an invasive insect that normally is controlled in the winter by the cold winters that kill the bark beetles off. But this is one of the areas that's been very hard hit by the bark beetles, being able to survive the winters and infect the trees and kill them. Now, I don't want to end on completely a down note here, so let me go back to Rondonia for a moment. Let's zoom back out and pan down to South America here. Let's go back. You remember how we noticed that the rate of deforestation was slowing down in Rondonia? Now, if you watch closely, you're going to see kind of these weird patterns emerge as we get to present day. You see kind of these weird outlines, places where it's like almost all farm versus almost all forest. So what's going on there? We're going to turn on another data layer. This is from United Nations Environmental Program, which records all of the protected areas across the planet. So let's turn that on. And you see those areas pop up. So if we zoom in a bit, you'll see these areas have been set aside in some way to prevent them from being deforested. Most of these areas in Brazil turn out to belong to indigenous peoples who have managed to document their claim to the land and become legally the guardians of their own land where they live. This area here belongs to the Surui people of Brazil, and you'll see they're doing a pretty dang good job of keeping it protected. You'll see a few places here where you have these illegal incursions and deforestation happening. And it's the case that today most of the Surui people have moved into villages along the border to try to protect their land from these incursions at some significant risk to themselves. So I want to end with that example because I think it shows how governments, how communities, how individuals can make decisions that really change our trajectory. We're not doomed, so to speak. The things that we're seeing are not inevitable. We do have the power to make decisions that change the future.